number 3, the first lesson in week number 2. So in the top diagram, remember we always include some review material. In the top diagram, we're looking at some vertical angles here. Angle 1 and 3 are always equal. So if 1 is 123, so is 3. And then 1 and 2 together are supplementary, right? Because they make a straight line. So 180 minus 123 is 57. And 2 and 4 are equal, so 4 is also 57. Now I went with the best choice that describes each triangle. And in some cases, I might have said, gee, you know, I don't know if it's exactly a right angle because they didn't put the symbol in there, but it sure looks like one. So number 1, they're acute. They're all less than 90. Number 2, that sure looks like a right angle. So I included that. Number 3, definitely obtuse. Number 4 is pretty sure it's acute. You know, it looks just less than 90 to me. So I think I'm right about that. But if you whip out a protractor and say, no, see, it's exactly 90, I hear you. It's close enough to think it's possible. Number 5 is acute, right? All less than 90. Number 6 is obtuse. That's a little bigger than 90. Number 7 is obtuse. That's a lot bigger than 90, that one angle. You can't have 2 obtuse angles in a triangle for reasons we will get to in our 4th lesson. Number 8, that's a right triangle because it sure looks like a right angle there. Okay, number 3, they tell you here that the measure of angle JZH is 31. That's this angle right here, okay? Find the measure of angle FZG. Well, that's the vertical to it, so that's also 31. Now, what about this guy up here? Well, this is a complementary situation. These two angles are going to make 90 degrees. So 90 minus 31 is 59. And as far as angle HZG goes, you can use either pairing here, but all I have to do is go here and show 180 degrees, or I could go here and show 180. It's the same either way. And that would be 180 minus 31, which is 149. Okay, find the missing angles here. They're clearly supplementary, right? We're making straight lines. So 180 minus 105 is 75. 180 minus 110 is 70. 180 minus 84 is 96. Number 5 is definitely not supplementary. Number 5 is complementary. And if you look, they're making a 90-degree angle. 90 degrees is such a critical angle. I turn my head to my right and I see more pieces of molding around the window that make 90-degree angles. I see 90-degree angles in the window. I see 90-degree angles in the planks of the flooring and how they meet the wall and the molding on the floor. I see 90-degree angles everywhere. So complementary is a very important idea. If one angle's 30, like if one piece of molding was 30 degrees, how would you have to cut the other one? It would have to be 60 degrees because you're going to get a nice right angle corner in the molding. That's why you have a thing called the miter box. Okay, next up, 90 minus 55 is 35. And the last diagram, 90 minus 40 is 50. So there's a review of complementary and supplementary. Now we're getting into a little bit of your proper terminology that we talked about at the end of lesson 3. Alternate exterior, well, you could be 3 and 8. Alternate means opposite sides of the transversal. Exterior means outside the parallel lines. So you could have 3 and 8 or 5 and 2. Same side interior. Interior means on the inside. Same side, pretty straightforward. 7 and 6 or 1 and 4. Vertical angles are any pair of angles that are across from each other. There's 4 different pairs. 5 and 7, 1 and 3, 4 and 2, 6 and 8. Alternate interior, that means in between the two lines, switching sides of this transversal. 1 and 6 could be the alternate interior, or 4 and 7. I forgot to answer corresponding and supplementary, so let me do it now. Corresponding is when you do drag and drop and they land on top. So 3 would land on top of 6, 7 on 2, 5 on 4, 1 on 8. So those are all corresponding pairs. And supplementary is any acute with any obtuse. So, for example, 1 and 5, that's supplementary. 1 and 7, 3 and 5, 3 and 7, 7 and 6, 1 and 4, 8 and 1, 2, pardon, not 8 and 1, I'm sorry about that. Let's see here, 8 and 7, 2 and 1. So there's many different combinations there. Next up, in the figure, line L is parallel to M. Tell what relationship we've got here. So 2 and 5, they're vertical, so they're equal. 3 and 7, they're inside and they're changing sides of the transversal, so they're alternate interior, they're equal. Corresponding, land on top, drag on drop. So 3 and 6 would land on top of each other, so they are corresponding and they are congruent or equal. 2 and 7 are consecutive, same side interior. That would be supplementary. They would add up to 180. 1 and 4 are vertical, of course, vertical or congruent. 6 and 8 would be alternate exterior angles. Okay, they're equal. Linear pair for numbers 4 and 7, and they would be supplementary. And 7 and 8 are corresponding because drag and drop, they land on top, and corresponding angles are equal. All right, so now we've got measure of angle 4 is 73. Let's find the others. Well, number 7 is 73. I could look at it as they're both acute, or if I did drag and drop, they would be vertical, or I could say they're just alternate interior angles, whichever method floats your boat. Number 1, that's 107. They're consecutive interior. One is acute, one is obtuse. Next up, number 17, angle 5. Well, if I do drag and drop, it would land on top. So they're corresponding angles, both 73 degrees, or they're both acute. So any way you want to look at it. Number 18, angle 2, well, that's vertical to it, and that would be also 73 degrees. Number 19, angle 8, that is a linear pair, so they're supplementary. That would be 107. And number 20, it wants the measure of angle 8, and I wasn't exactly sure from this, find angle 3. I think that's what they were trying to say. But since they're a linear pair, angle 8 is 107, which we just did on number 19. And then angle 8 is congruent to angle 3 by alternate exterior. So that is also 107. All right, then we have a few equations using some algebra work and all of that equation stuff we've been emphasizing. In this case, we have alternate exterior angles, or if we did drag and drop, they'd be vertical, or they're both acute angles. Any way you want to look at it, they got to be equal. So 7x minus 20 equals 4x plus 16. Opposite side, opposite operation. So we're subtracting the 4x from both sides. That gives me 3x minus 20 is 16. Adding the 20 to both sides, 3x is 36. Dividing by 3, x is 12. Okay, in this particular case, number 8, well, one is acute and one is obtuse. Or if I did drag and drop, they'd end up making a linear pair. So they've got to add up to 180. Same side, same operation here with the x's. So 4x plus 3x add up to 7x. I get 7x plus 19 is 180. Minus 19 from both sides. 7x is 161. And dividing, and I get x is 23. Number 9 is a little tricky because it says to find both x and y. So I'm going to concentrate on the y's first. And what I notice here is I have an obtuse and I have an acute. So they got to add up to 180. Same side, same operation. That gives me 8y minus 4 is 180. Adding the 4, 184, dividing by the 8, I get y is 23. Then I have to use that value to figure out what 3 times 23 is, and that's 69. And then this 69 degree angle here where it says 3y, well, that corresponds to the 2x plus 13, so they're equal. Subtracting 13, 2x is 56, dividing by 2, x is 28. So that, folks, is homework number 3.